Discovery and alert. NASA has just activated its Earth Defense Group, a decision that startled the public and the scientific community alike. Few had any idea such a network existed. The reason for the activation? Concerns over a potential, Manhattanized, comet, an object of unusual size and speed, possibly carrying elements never seen before, or even hints of alien technology. Initially, a faint object was detected drifting across the constellation Pegasus, barely visible to astronomers' telescopes, seemingly just another distant, icy wanderer in the dark void of space. At first, it seemed unremarkable, insignificant, just another transient object in our solar system's outskirts. But within days, its motion began to defy all expectations. The speed, angle, and trajectory were unlike anything observed before. This object, later confirmed as 3I Atlas, was not gravitationally bound to the Sun. It was an interstellar traveler, a visitor from another star system, moving through our solar system on a hyperbolic trajectory at incredible velocity. Traveling faster than any comet or asteroid ever recorded, 3I Atlas cut across the solar system like a cosmic arrow, unbound and relentless. Its designation, 3I, identified it as the third known interstellar object to reach our solar system, after the enigmatic Oumuamua and the icy comet Borisov. What startled the global scientific community was not just its alien origin, but the combination of its mass, velocity, and unusual composition, a puzzle that defied conventional astronomical understanding. Within days of confirmation, NASA's Planetary Defense Coordination Office issued an unprecedented alert, activating the entire Planetary Defense Network to monitor the object in real time. This network was designed to track near-Earth objects, asteroids and comets that might pose a threat to our planet, but never before had it been called upon for an interstellar visitor. Its protocols were written for familiar hazards, errant rocks wandering the solar system. Not for something that had traveled light years, untouched by our sun's gravity, to briefly pass through our celestial neighborhood. Tracking 3I Atlas became both a milestone for human technology and a sobering reminder of our vulnerability. Across NASA's Deep Space Network, massive antennas locked onto coordinates relayed by the Atlas Survey Telescope in Hawaii, which had first detected the object. The Minor Planet Center issued rapid updates, recalculating its orbit as new observations poured in from around the world. Moving at nearly 60 km per second, it was set to pass 0.8 astronomical units from Earth's orbit before slingshotting back into interstellar space. Its speed ruled out any chance of capture or deflection, yet interception was never the goal. The priority was to understand it, to decode its mysteries. Ground and space-based instruments, radars at Goldstone, infrared telescopes in orbit, and optical arrays on every continent, shifted focus toward this unprecedented visitor. International collaboration became essential. ESA in Europe, JAXA in Japan, and observatories across Chile, South Africa, and Australia joined the monitoring campaign, creating a planetary-scale network of vigilance. Supercomputers ran simulations, modeling how the object's spin, irregular shape, and surface composition might influence its path, as scientists scrambled to make sense of the unknown. Early results revealed something extraordinary. 3I Atlas was not merely a chunk of ice or rock. It exhibited unusual reflectivity, density variations, and hints of metallic elements buried beneath volatile layers, suggesting a complex history in the inner regions of another star system. Scientists debated its origin. A natural fragment flung into space during planetary formation? A relic of interstellar collisions? Or, in more speculative circles, a fragment of artificial construction? While NASA remained cautious, insisting there was no evidence of artificiality, the global fascination was undeniable. The Planetary Defense Network was evolving in real time, pushing its sensors, radars, and spectrographs to their limits. Algorithms designed to predict near-Earth asteroid paths were recalibrated for an object moving at interstellar speeds, accounting for unpredictable tumbling and outgassing. Every observation mattered, every radar echo, every infrared spike. Each was a clue in a cosmic detective story. Observation, discovery, and legacy. The monitoring of 3I Atlas became an exercise in global coordination and technological mastery. Data flowed continuously across continents, observatories synchronized observations, and students and researchers alike contributed to real-time tracking, blurring the line between education and discovery. Infrared and radar readings revealed subtle details, complex chemical composition, surface irregularities, and signs that 3I Atlas may have originated in a star system rich in heavy elements. Unlike ordinary comets, this object provided a window into alien planetary formation, a glimpse of distant worlds billions of kilometers away. The activation of the Planetary Defense Network wasn't just about safety, it was an act of curiosity, anticipation, and global scientific unity. Scientists, engineers, and agencies worked together, blurring the line between defense and discovery, pushing technology and imagination to new limits. As 3I Atlas moved outward, fading from sensors, its legacy persisted. Humanity's capacity for observation, collaboration, and innovation had been tested and proven. Plans emerged for autonomous, AI-driven orbital sensors, capable of tracking interstellar objects long before they could be observed by humans. Beyond the technological achievement, the event had philosophical and cultural significance. To protect our planet, we must first understand the cosmos. Observing carefully became an act of stewardship, vigilance became an act of wonder. Even after the object departed, analysis continued, refining models, recalibrating instruments, and preparing for the next interstellar traveler. 3I Atlas had traveled billions of years across the galaxy, now leaving humanity with a glimpse of another star system's history. Its detection reaffirmed the necessity of global collaboration and the power of integrated planetary defense infrastructure. Radar, telescopes, and orbital sensors were synchronized into a single coherent system, with AI algorithms flagging anomalies and predicting minute-by-minute trajectory changes. Each data point revealed the object's story, chemical composition, structural irregularities, and interactions with solar radiation, providing clues about alien worlds and the forces shaping them. The event transformed the Planetary Defense Network from a simple alarm system into a framework for discovery, exploration, and education. Universities, students, and civilian observatories became auxiliary nodes in a global monitoring system, contributing to the understanding of interstellar physics in real time. Observations of absorption lines in metallic compounds suggested that 3I Atlas might have once been part of a planet large enough to experience geological processes before being ejected into space. The realization that a fragment of another world had passed through our solar system ignited imagination and scientific inquiry alike. The Planetary Defense Network, initially designed for protection, had inadvertently become a mechanism for interstellar anthropology, allowing Earth to witness firsthand the remnants of alien planetary evolution. Beyond science, 3I Atlas carried profound cultural weight. It symbolized human curiosity, global unity, and our evolving relationship with the cosmos. Months after its passage, the network continued to refine models, improve predictive algorithms, and prepare for future encounters with objects from beyond the stars. 3I Atlas had traveled billions of years to visit our solar system for a brief, fleeting moment, leaving humanity with an enduring reminder. To watch the skies is to understand our place in the universe. It was not just vigilance, it was wonder,